Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mickey.
And I'm Olivia. For math homework help, call in Bakersfield 636-4357. Everywhere else, call 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Nicely done, Olivia. So where do you attend school and what grade are you in?
I attend school at Stockdale Elementary and I'm in 6th grade.
What are you looking forward to? Because you're going to have to leave Stockdale next year. What are you looking forward to in junior high?
I don't know.
Multiple classes.
Yeah, do you
Yeah.
think you'll like going to
Well,
different
yeah,
classes?
probably. I want to have like different teachers.
Okay, so you're definitely going to have that. So every period you're going to have a different instructor.
Mm-hmm.
All right, so you're going to like that, as far as you think you're going to like that.
Yes.
Right? Are there any extracurricular activities that you think you might want to be involved in? Like music or sports or anything like that?
Chorus and volleyball.
Okay, so chorus and volleyball. And I think, but then I'm sure chorus will start when the school year starts, but I don't know about volleyball. Do you know if they start that before school?
Usually September.
Okay,
Yeah,
so you'll be in
usually
school
a couple
already.
weeks in the school, yeah.
All right. So a couple of things to look forward to.
Mm-hmm.
What do you think you'll miss about being at Stockdale for so long?
Probably like all my friends, because a lot of them are going to Tevis or Actis or Warren.
Okay, so you guys spread out quite a bit then as
Yeah.
far as going to different schools. All right. Well, you know what? I'm sure you'll still be in contact with them a lot.
Yeah.
Maybe just not going to every class with them and stuff like that. Plus, you have an opportunity to make a lot more new friends, right? All right. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. However, programming note today, the 18th and 19th of this month are the final 2 live broadcasts for Do the Math for our 23rd season. It's a long time, Mike.
Yeah, it's been a long time.
I know. Well, you've been here for all 23 seasons, maybe not
Yeah,
on air.
Yeah,
with
maybe
me
not on
doing it,
air, but
you've been
doing
part of the
something,
show,
yeah.
as well as Mac, and been here for 23 years.
Last couple, I decided to join the
That's
hair
right.
club.
Keep it low,
That's right.
bro.
That's
Keep it
right.
low, right?
Got to keep it together.
Easy maintenance right there. Anyway, so just a programming note. These are the final 2 live broadcasts for our 23rd season. Do the Math will continue to be on. However, they'll just be rebroadcast of this year's shows. And we will also have new and exciting things coming up on social media throughout the entire rest of the spring and summer, right up until we start season 24 in September of 2025. Are you ready to help me out with our social media problem of the day?
Yes.
All right, let's take a look at it together. So go ahead and read that for us, please.
Mike spent a day and a half hiking. He was going uphill for 5/6 of that time. What fraction of the day was Mike hiking uphill?
All right, so when you look at that, what do you think of, how do you think we're going to solve this? Because it is kind of confusing because, like I said, this is our social media problem of the day, and I don't think anybody answered it correctly. So what do you think we should do? How do you want to approach this problem?
He spent a day and a half hiking. And
All right, so we're going to need that information,
Yes.
right?
Oh, it just dawned on me. Sorry, I was even struggling for a second there. I was like, I'm
Right,
not getting
so it
it.
takes
I
a
got
minute
it. Okay, all
to
right.
figure it
Took a
out,
second.
all right? So a day and a half. What do you think we're going to do with that day and a half? Because that is an important number.
make it a fraction.
Okay. So a day and a half, so that would be 1 1/2.
Yeah.
But we don't really want a mixed number if the other number is a fraction 5/6. So how can we turn that mixed number into a fraction?
We multiply and then add.
And what would that become?
3 halves.
3 halves, right? So it would be 3/2.
Yes.
And we have to use that 3/2 and do something with that 5/6, right? So we spent a day and a half, we were going uphill for 5/6 of that time. So what do you think we're going to do with those two fractions? Add them, subtract them, multiply them, or divide them? Because there's only 4 things we can do with them.
Multiply.
Multiply them. Why multiply?
Why not?
All right, well, you know what? That's the thing. Let's try that first, right? So let's just think logically and reason about this first for a quick minute. You're hiking for a day and a half, and you were going uphill 5/6 of the time. Do you think we would need to subtract those numbers for any reason?
Yeah, probably.
Okay, well then let me ask you this. If we spent a day and a half hiking and we're going up the hill 5/6 of the time, do you think we would have to add those numbers at all?
Yeah, I mean.
Okay, so you've given me a yes on the subtraction, a yes on the addition, and you said multiplication. So why not
Yeah, we're
division?
doing all 4, right? Are you going to do it 4
Or do
different
you
ways
think we
and get 4
should
different
divide them?
answers?
Probably not divide.
Okay, so we can wipe divide out of there.
Yep.
All right. So let's take a look. So it says, what fraction of the day was Mike going uphill? Right? So you wanted to, first of all, multiply. So we're going to take 3/2 of 5/6.
I like the word of.
Right, because that implies multiplying.
Yeah, like if you go to the store and you buy 4 of something, it's 4 times that cost.
Whatever it is
right?
you're getting.
So of is a pretty important mathematical keyword in a lot of problems.
So think about 3/2 times 5/6,
15/12.
15/12.
All right.
Now, if you simplified that, what would that be? What goes into 15 and 12?
3.
Okay, so if we divided each of those by 3, what would we have?
5/4.
Is 5/4 an answer up there?
Yes.
All right, so we possibly are on the right track because we're doing this because you said, why not? Right?
I like that. I like that. Kids ask, why do we do it? Why not? That's
So
what we're
if we
doing.
have 3/2, 3/2, and 5/6, can we simplify things before we even multiply? Have you ever seen the cross simplifying? So
Yeah.
the 3 and the
Not
6.
good at that though.
Okay.
That's all right. That's why we're here to do the math.
We're going to do it in our head a little bit, right?
Okay.
So opposite the 3 as the numerator, the 6 in the denominator. What goes into 3 and 6?
2. Oh, no. Wait. 3. 3.
Right.
Yeah.
And it goes in once and twice, right? So now we have 1/2
Okay, 1/2.
and 5/2.
5/2.
Close. 2 times 2 on the bottom.
Oh, 5/4.
5/4. So once again, we could simplify it a little bit and still get 5/4. So are we going to go with 5/4 on this?
Yes.
All right, let's see if indeed C is the correct answer. There we
Yay.
go. Hey, you know what? Why not? Let's go and multiply
Why not?
first.
I
And
like
the
it.
key is, as you said, Mick, that word of is what implies that right there. Time now for today's Math in the News. And in studio with us right now, we have Marylou. How are you?
Good. How are you doing?
I'm excellent. So you are one of our regular math tutors.
Yes, I am.
But you are not dressed as a regular math tutor today.
No, I am not.
Because you work most of your time when you're not helping out with Do the Math for the Kern County Superintendent of Schools.
Yes, I do.
And what is your role with the office?
I am a math coordinator with the Kern County Superintendent of Schools.
And what does that mean for students that go, well, you're a math coordinator, so are you a math teacher, or what do you do?
Well, I get to have lots of fun with educators and students all throughout Kern County. I get to go onto campuses and work with teachers. I get to work with students, work with administration, and looking at mathematics and thinking about the new framework and best practices in a math classroom.
And I know last week, I think it was last weekend, you guys had your Central Area Conference
Yes.
for the CMC.
Yes, we did.
And that was a pretty big event. I was able to go and learned a lot, and we did a couple of things that I did there, and we were able to share them on the show. So what was the biggest thing you guys think you're always looking for with that conference as far as educators go?
I think really when they're planning that conference, it's who can we bring in from the math community to really help and support the teachers of Kern County. But the conference, as you saw, is just not teachers from Kern County.
Right.
It was teachers all up and down the state of California, which makes it pretty awesome.
Right, and then you have presenters coming in
Yes.
from throughout the country and throughout the world also.
Yes.
There are people come from other countries to present at this conference.
Yes, we do.
Now, we have a big week coming up next week.
We do.
So why don't you head on over to the board, and we're going to talk about Math Week coming up next week.
Yes, so we have the CMC Central Math Week. Now, it has been going on, this is the 3rd year, but this is the first time it is central. The last 2 years has been Kern County only, but now it is through the central. As you could see, all of these different counties are involved, and it's really fun. What the CMC Central section, what Math Week is all about is how do we bring math to families, and we can do that through games. Do you like playing math games?
Yeah.
Okay, so this is our website, and you'll be able to find that again on Do the Math website. If we scroll up, what we have is we have an impact tracker that can kind of keep track of what families are playing and how many total minutes. We have directions in English and Spanish. And also we can choose the day. So if we're starting next Monday, you would choose day 1, okay? And on day 1, we have stories, which is the big thing from Mind Research. They have put stories and games all together. And again, we have it in English and we have it in Spanish. So we have these stories to go along with the game. And this is one of my favorite games. Have you played this before? No. Achi? Okay, so there's a wonderful story. If we click on this, we're gonna quickly kind of go through this. It tells us the story of Achi. And we can turn the page here. It goes through, it's kind of similar to tic-tac-toe. Do you like tic-tac-toe?
Yeah.
But don't you get upset when you tie and there's no winner? Well, Achi, will be a winner. So we're gonna play this game here in just a second. So there's a story that we can go through and learn about Achi. And then it kind of shows us a little bit about the board, and we can see it's a little bit different than tic-tac-toe, right? So again, it's 3 in a row though. And here we go. We're gonna play this in a second, going through it. So you ready to start? Would you like red or would you like blue?
I'll take blue.
Okay, so I'm gonna let you start, and you can put your pieces, just drag them over on any dot. Again.
And as you're playing this, Marylou, I know there are
See.
some students
Oh, you
or
go first.
educators,
Oh, okay.
and they might go, that looks
Yes.
like Nine Men's Morris. Just a different name.
It's just a different
Right.
name, exactly. Okay, now your turn. I went ahead and moved. Did you move? Okay. I'm gonna go there. Oh, you blocked me. All right. I'm gonna go up there. And, oh! Didn't even see that. Good job, good job. So, if we say that we tied, right? And I'm gonna have you go again real quick. Say that if we tied, and this time let's just not try to, go ahead, move something real quick.
Well, your move wasn't
Oh.
on there. There you go.
Did it not stick? There you go. And there you go. Oh, let me just go there. And let me just move there. And then move one right there for me. So even though we did not win, we didn't get 3 in the row, we can continue this game because you can slide something to try to get 3 in a row. So play will continue. There you go. Boom. And you could slide and win, okay? And what I really love is that there are other ways to play. So we have some more, they're extending it to different formats.
Okay.
So it is a fun math week again to try to get students and family to play wonderful games. Thank you for playing with me. Just getting them to play.
Right, and as the students continue, it gets progressively more difficult as they
Yes.
continue on those levels right there.
Yes, and there is a tracker. It is down here real quick. There's a tracker to keep track. So once you play, you go to gameplay data, and it is a Google form that you can
Okay.
keep track of how many minutes you played, what school you're from, what grade you're from.
And that way, it's kind of a little competition between schools and maybe even classes in schools and
Yes.
things like that. So I know there are
Big,
places to
yes,
do that.
big
So anyway,
competition.
coming up next week, the 24th through the 28th,
Yes.
they can go through the Do the Math website and
Yes.
find out information about it. And I'm sure even kern.org will have it also
Yes,
as well.
it will.
All right, nicely done. So Marylou, nice to see you again.
I know,
And,
nice to be here.
Maybe if you stick around, we'll make you do some more work later on. We'll be back with more right after this.
Hello, I am Jordan Fernandez. And I'm Ewan McPherson. And today we're going to be showing you a number pattern. So first, we're going to need a 3-digit number.
123.
123. And now we're going to write our own secret number in that paper right there.
Yes.
Fold it up. Okay, now we're going to need another 3-digit number.
267.
267.
We're
Now
gonna add our own number to that number.
And now we need another 3-digit number.
823.
Again, we're gonna add our own number to that.
And then one last 3-digit number.
455.
We're gonna add a last number to this, and then add it all up.
$3,120.
And if we open up this paper, 3,120.
Okay, now to explain this trick, we're going to kind of just set it up for you. So you give us a 3-digit number, and because we need to write down our own number before you give us another one, we add 2,997.
Why 2,997?
Because when you add these numbers up, you get 9.
It's also the same for the other two columns, which their numbers add up to 9.
So when you give us a number, we arrange the numbers to equal 9. See, 9, that was a bad 9, and 9. So now when you add up 999 plus 999 plus 999, you add them all up, you get 2,997. And when you add that to 1,123, you get 3,120.
Another easier way to do this is by subtracting 3.
So
Subtracting 3.
you get
No,
what?
it's- yeah,
120.
subtracting-
And if you just add 3,000,
And subtract 3 from 123,
you get 3,120.
which is the answer we got.
Okay. That is our
That is our
number trick. Thank you. Very cool.
Nice to see the boys working on that problem, and always a couple of different ways to solve all types of math problems. In studio right now, we have Olivia, a 6th grade student from Stockdale Elementary, and I've got a beautiful problem for you guys to start.
I thought you were going to say a beautiful co-host or a beautiful tutor over here, but I guess that
You're just
works.
lovely, Mike. Get
Oh,
over
thank
the
you,
board,
thank you, thank
guys.
you.
All right. So, Olivia, you've got a bunch of hexagons over there, and they're in lines of 3, 4, or 5 going different ways, diagonally or vertically, okay? You want to use the numbers 1 through 19 so that no matter which way you add them up, they always add up to 38,
Okay.
okay? And what's one thing, because I know you've started working on this as part of a homework problem.
Yeah.
What's one strategy you've come up with already to kind of make it a little bit easier on where to place some of the numbers?
To put the bigger numbers in rows of 3 and 4. So like here.
If you want to go ahead and
Or
grab
here.
the pen and we can start going for it.
I'm going to give you a hint here also, right? Down at the very bottom, right in the middle, you're going to put a 3. And right in the very middle of everything, you're going to put a 5. Now, based on that, looking at the 3 and going up to the left and up to the right, you know you have to add up to 38.
Yep.
So each of those two sides have to add up to what?
30.
35.
35.
Sorry, 35.
Right? So if you have a 17 right there next to the 3, what has to be above it?
18.
Right. So you're going to erase the 18 you've got and move it over to the other side.
All right, so now that we have that one there, we can also think this needs to also be, these 3 connected need to also be what?
38.
So 18 and 16 gives us,
20. Wait.
don't forget to regroup,
32.
close.
34.
There we go.
But that's a little high because that means you're going to have a 4 outside, and you don't want any single digits outside really if you can help it.
So maybe the
Okay,
16.
So maybe get rid of the
of-
16.
Yeah.
And maybe here's a clue for you. Instead of 16, go down lower by the number in the middle.
11.
So you guys on your way?
So we got 18 and 11 makes,
Right, so what I'm going to do is I'm going to let you guys keep going on that because right now we're going to head downstairs and check out some of the art in mathematics.
All right, hi, welcome back to another day in art. It's our final one of this season, and today with us we have Dre from the Bakersfield Museum of Art. Thank you so much for being here.
Thank you for having me.
All right, so what is our project today?
So today we're going to be doing Piet Mondrian inspired watercolor art. So basically we're going to be using our 10 blocks, so hundreds, tens, and ones. We're going to be rolling dice, and we're going to be seeing how much of everything we're going to do.
All right, so they're gonna have their dice, right? So they're gonna give this dice a roll, right? So if they get 3, then they'll be using the 10 base, no, 100 base 3 times, right? So however they want to apply it on their page. They'd roll again, oh, they get another 3, then we're gonna go to the 10s, and they'll roll it again, and then use our 1s. And so then we're having, primary colors, right?
Yeah, so Piet Mondrian used primary colors in the painting that we're inspired by today. So we're going to be using primary colors, and yeah.
And maybe some black and white. And then, so if they roll these dice once, do they only do it one time, or can they do it multiple times if they want more?
They can do it multiple times if they want to. It's always their own art. They can put their own twist on it. So yeah.
All right, so we're using some math and some art again together in our art. So we'll be back a little bit later and we'll see their progress. All right, back to you, Mike.
All right, thank you for that, Sam. Well, right now we've got Olivia and Mickey working on this hexagon problem. And you had your little clue of 3 down at the bottom.
need 19 more in here.
So where are you guys at now?
What do you think? Well, we've done 6 and 2 in the middle to make 38 diagonally through the middle there from left to right or right upper to the upper left. Now we're just starting to play with numbers. Like we just plugged in a 6 and a 7, but realized 9 and 6 or 9 and a different number would require us to have like 21, and that's too large. So continuing to play and
So
see.
everything you've got is perfect thus far.
For what we've solved, yes. Doesn't mean it's going to work with everything else we've done, but what we have so far works.
But
yes.
everything works.
Yeah.
So why don't we take, let's take the 16 and go up. So how many do you need? Leave the 16.
Oh.
But how many more from there? And figure out what you think those 2 would be.
We need 422. Wait.
You talking about this one right here, Mike?
No, go to the 16 and go straight up where she's at.
Oh, I get you. Sorry, it took me a second. What? Okay, so how much more do we need? 38 minus 16.
8, sorry. 18. Wait, no. 22.
There we go. Okay.
I had it.
You're on it. You're on it. I believe you. So how do we get 22 out of that? What do you
We
think?
could do 10 and 12.
Okay, go for it. Let's plug it in, see how we do. Wherever you want. No pressure. Oh, God. No, I'm just kidding. You're doing great. All right, so now we have 17, something, 2 and 10. 2 and 10 is 12. 12 plus 17.
It's 29.
Okay. Well, what would we need to make that work?
9.
So maybe we flip these, and then that helps us reduce what we need by 2. Let's try that. All right, so now 12 and 2 is 14. 14 and 17 is?
31.
Okay, and what do we need right there in the middle then?
7.
Aha, so that'll work. And now we're down here, 19 and 11.
30.
plus 7.
37.
So what do we need right there?
1.
All right. Then we have this one set up. So 18 and 1 is
19.
plus 5,
24.
plus 10.
34.
And what else do we need?
4.
Nice. All right, so now we're getting down. It's getting kind of close, right? So let's see. Final 4. Which one do you want to start with?
Let's go here.
Okay. 17 and 1
18.
plus 6.
24.
How much more do we need?
14.
Okay. Looks like we haven't used a 14 yet. Go for it. All right. 3 more. No pressure. We're getting there.
9 plus 14.
Okay. I believe in you. Rhymes with 20 free.
23.
There we go. All right. 23. All right. Let's put a 23. Oh, sorry. We have 23. How much more do we need?
15.
Okay. Let's plug it in. Ooh. Where do you want to go next? 2 options.
Here.
All right. Talk me through it. What you got?
Okay, so this is 10. 15 plus 15 is 30, so we need 8.
Can we use? Do we have used 8?
I don't think so.
All right. Looks good to me. 1 left. We could count 1 through 19, or we could just figure it out.
25, and we need 13 more.
Okay, plug it in. And we'll look to Mike, who apparently is a beautiful host, but does not have a most beautiful co-host. So Mike, how are we
Easy,
looking?
You're just lovely also there.
It's,
Mike.
you know, I tried to copy the hairstyle. It's not getting me any points. Mike, tell us how do we
You
do?
know what? That's nicely done because basically I gave you the 3 and the 5, and that was it, right? Because using the 3, that's a key. You need a key to start, right? Otherwise, it would take you just a long time to kind of figure it out.
Yeah, it's almost like a Sudoku without a rhythm or a rhyme. You're just
Right.
plug
And
it in.
this is the only way to do this problem. Now you could reconfigure it where you had the 15 at the bottom, but then you're going to rearrange everything else.
So it's really just like rotating it, but these numbers
Right.
have to be touching the other numbers they're with.
Right. So nicely done, Olivia. I was impressed in how quickly you guys were able to get that done. So because of that great effort, you've got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations.
Yeah,
on that.
Chick-fil-A.
There you go. Everybody love Chick-fil-A. We'll be back with more right after this. All right, I know that we're going to go downstairs. I know that they were doing some art and they were using some cubes and 10 rods and things like that, and using Mondrian primary colors. So Sam, where are you guys at right now?
Okay, so the kids have all rolled their dice, and we've written down on their piece of paper whatever they got for the hundreds, the tens, and the ones. And so that's what they got to use to create their piece of art. And, you know, if you didn't really like your number, you got to roll the dice again. So let's take a look at some of the kids that have started working already. So here he had 200, 6 tens, and 4 ones. So far he's traced his 100 block twice. And his tens, he's working on those right now. And you can see he's keeping it very much in the style of Piet. All right, so then he's gonna have 4 ones. So then once they finish this, they're gonna be tracing it with a Sharpie, correct?
Yes.
Okay, and then they will go with that. So what about you? What numbers did you get? 3, 4, and 2. I like what you got going on so far. Nice balance. Very cool. And you already created some extra rectangles in the overlap. Very good. All right, well, how about you? What were your numbers?
1, 3, and 6.
Ooh. So tell me how you got your 1, 3, and 6 going here.
I'm gonna be using one of the 100 blocks,
Okay.
6 of the 10s, and 3 of the ones. I'm just using these so that I can keep it, the extra ones, to keep it accurate and stuff like that.
Oh, okay. So you've created more lines, but then you're gonna put those on top of this one?
Yeah.
Oh, okay, I like that. Branching out. Okay, now over here at this table we have, all of these girls have taken it the more unconventional way, but we're liking their abstract ideas. So how many have you got here?
I've got 6 hundreds, 6 tens, and 5 ones.
All right, and I like how you've got them all overlapped.
Yeah.
Nice, you two have nice balance. How about you?
So I got 300, 6 tens, and I'm trying to do my 12 ones right now.
12, oh, I like that, yes, okay. All right, and back over here.
I got 500, 5 tens, and 6 ones.
All right, those look great. And she's already got her Sharpie going. Nice, what were your numbers?
600, 3 tens, and 5 ones.
All right, okay, I like this balance you got going. And so Dre, you were telling me a little bit about Piet and his artistic life.
So he actually was a figure painter in the beginning of his life, and as he got older, he actually became more of an abstract artist, and he used a lot of geometric shapes, and that's exactly what we're doing today.
Yeah.
So math can be fun. Math and art together can be fun.
That's right. All right, so these kids are going to continue to draw, and then we're going to trace them with the Sharpie, and then they're going to get to use the primary colors and black and white with watercolor to paint them. So I think that we'll send that back to you, Mike, and we'll see you in a little bit.
All right, thanks, Sam. Looks like a great project right now. So nice to see that they have an opportunity to roll the die and see how many of each of those different 100s, 10s, or ones that they're going to be able to use, overlap them a little bit, and make a little art out of that, and also kind of figure out the differences, if they hadn't already, between the 10s, the 1s, 100s, and how they relate to each other also.
Yeah, that was really interesting. You know, a lot of times we use them for understanding powers of 10 or the base 10 number system.
Right.
But to use them as a piece of art, I think I've never fathomed out. To me, it's just, oh, those are the 10 blocks. I use them for adding or talking about regrouping.
Right, and place value.
Yeah, never thought about really using them as an art piece.
Well, there you go. Well, that might be something.
I know what I'm doing tomorrow
in
in class. We're going to do something a little different tomorrow, yeah.
Yeah, and I understand that you are also part of a class where you guys implement math and art quite a bit also. Mm-hmm. So that must be some fun. Mm-hmm. Good. Are you ready to do some math right now?
Yes.
All right, so head on over to the board. I know that you're working on some equations also. So here's the first one. So Mick, if you want to write it down, 6x plus 7 minus 2x is equal to 3 plus 5x minus 9.
Thanks. All right, I didn't realize it was going to be that long. All right, well, what do we notice? What are you thinking? What are your thoughts?
I think we should first combine the like terms.
Okay, now you say like term. Now for students watching at home, or anybody really, what do you mean like terms? Like they are alike, they like each other? What do like terms mean?
the ones with the variables next to them, like combine them, and then the ones without a variable don't combine them, but
Okay, so you like 6 has an X in it. That's not 6 times, that's 6 actually connected with the letter X or the variable.
Yes.
Okay, so that one has a variable. What about the 7 here?
no, it does not have
Okay, so I couldn't combine those together to make like 13X.
no.
Okay, so I can combine 6X with what on the left side?
Negative 2x.
Okay, so I noticed you said negative 2X. It's really interesting. Students a lot of times will say minus 2X. So in this case, if I have a 6X and a negative 2X and you say we combine them, students think add, but is that what's happening here?
No, you're subtracting.
Okay, so when we do 6X combined with the negative 2X, what's left?
4x.
Go for it. So now we have 4X.
Plus
All right.
7 minus,
No minus 2X because we used it?
yep,
Okay.
equals, now we gotta figure out this side.
Okay, so like it's not that they go away, but that when we combine them, they've been used, but the plus 7 was not, so we rewrite it again.
Yes.
Okay.
Okay, so we would do 5x.
Because there's nothing else with an X?
Yes.
Okay.
And then 3 plus negative 9, which would be negative 6.
Now, do you have a strategy in your head as to how you do 3 plus negative? Because someone might think 3 plus negative 9, that doesn't make sense. Is there a way that you kind of think about that to understand it becomes negative 6?
I just subtract it.
3 minus 9, or did you minus 9 minus 3?
9 minus 3.
Okay, so because you know they're opposites, you know that as a fact
no,
family.
I add it, sorry.
You add it. So
Yes.
if I was saying like I had $3 and then I added a bill that was $9, now I owe.
$6.
Okay, all right. So that's a way. So
Yes.
someone was like, "What in the world does she mean add it together?" Okay, I get what you're saying. All right. Well, now on the left side we have nothing else to combine. Nothing else has the same variable, and on the right side the same thing. So how do we put stuff together? Are we done?
No, we
Okay.
want to isolate the x, so we're going to minus 4x on each side.
Oh, and it's an
With an
equals
X.
sign. So whatever you do on one side, it has to equal that on the.
Other.
Okay. So 4x minus 4x, we have.
7 equals x minus 6.
Okay, so 5x's, take away 4x's, we have 1x left. Do we have to put the 1 in front?
No.
Because it's just 1x?
Yeah.
Okay.
So now the x is still bothered by the negative 6.
Bothered, man. All right, all right. How are we going to
So-
unbother it?
Add 6 to each side.
Okay, now you keep saying add, even though it says subtract. Do you know the term, what you're using? When you're like, oh, I see it's minus 6, I need to add 6. Do you know the official term for that?
No.
It is called inverse.
Oh yeah, I did know.
Yeah,
that.
okay, yeah,
My
I was
teacher
to say
taught me
most
that.
students have heard of it, they just don't think about it very often. You know, a lot of teachers will say do the opposite. The academic term would be inverse operations or the opposite, and that's what allows us to manipulate an algebraic problem just like you're doing.
Yes.
So go ahead and finish it off for us.
X, and then 7 plus 6 is 13.
All right, now I know we don't have to check it right now, we don't have that much time, but if you wanted to make sure that the x really did have a value of 13, what could you do to make sure it actually worked?
You would put, my teacher calls it plug and chug. She puts the 13 where, or any number that's here, where the x's are, and then do it as a regular problem.
Now, one thing, I know we're not going to check it, but if I were to do that and you said, okay, 6 and then an x, so instead of x is really 13, so would I put 613?
No, you would do 6 dot times, or just put the number next to it.
Okay, so really when the 6 is directly connected with the variable, it actually represents multiplication.
Yes.
Okay, so if someone at home wanted to try this out because they're learning or they thought this was interesting, it's not 613, it's really 6 times whatever value, in this case 13? Uh-huh. Okay, Mike, how do we do? X
There you
has a
go,
value of 13?
perfectly done. And you know what? I'm glad that you were such a problem solver. You were able to figure out how to not bother that negative 6. Or bother the
I want to use that one in class. It's more like
I don't want that
make it- I
negative
wanna
6
get it, I wanna
bothering
be
the
bothering
X
it.
up there. So nicely done. Great problem right there, Olivia. Hey, we'll be back with more right after this.
Looks like I'm getting some kind of warning alarm. What is that? It looks like our ship is getting hit by asteroids. Or maybe it's comets. Actually, I don't know what the difference is.
Well, then let's learn about asteroids and comets. Both of these celestial objects roam our solar system, but they're quite different from each other. First, let's talk about asteroids. Asteroids, sometimes called minor planets, are remnants left over from the formation of our solar system. They are mostly found in the main asteroid belt, between the orbits of Mars and Jupiter. We passed it on our way out here. Asteroids are small, rocky objects that orbit the sun like planets. Since asteroids formed at the same time as other objects in our solar system, these space rocks can give scientists lots of information about the history of planets and the sun. Scientists can learn about these asteroids by studying meteorites, tiny bits of asteroids that have broken off and crashed on Earth's surface. Asteroids can be different sizes, from tiny boulders to massive rocks hundreds of feet wide. Some asteroids are even hundreds of miles in diameter, but many more are as small as pebbles. Most asteroids have jagged and irregular shapes with craters and ridges, and they say that no two asteroids are the same. They are made of different kinds of rocks, but some have non-metallic minerals or even metals, such as nickel and iron. Asteroids don't just hang out in the main asteroid belt. They can be found in other places too. Some can be found in the orbital path of planets. This means that the asteroid and the planet follow the same path around the sun. Earth and a few other planets have asteroids like this. But because we're out here by Neptune, the objects triggering our alarms could be comets coming from the Kuiper Belt. Like the main asteroid belt, this region is home to leftovers from the solar system's early history. The Kuiper Belt is truly a frontier in space. It's a place we're just beginning to explore and learn about, and is one of the places comets come from. Comets are often described as dirty snowballs because they're made up of ice, dust, and rocky material. When a comet gets close to the sun, the heat causes its icy core to vaporize, creating a glowing cloud of gas and dust known as a coma. This vaporization also forms the comet's spectacular tail, which can stretch for millions of miles. Let's recap the key differences between asteroids and comets. First is their composition. That means the materials they are made of. Asteroids are made of rock and metals, while comets are made of ice, dust, and rocky materials. Next is their location. Asteroids are mostly found in the main asteroid belt, but comets come from the Kuiper Belt and a place called the Oort cloud, an area beyond our solar system. The last thing is how they look. Asteroids are hunks of rock, while comets get glowing comas and tails as they get closer to the sun. Both asteroids and comets are essential to understanding our solar system's history and evolution. They provide clues about the early solar system and the building blocks of planets, moons, and even life.
All right, well, Olivia, you did so well with that last one. How do you feel about one more?
Sure.
All right, head on over to the board. You guys have one up on the board. And Olivia, you're going to basically go through this one, instructing Mickey what you're doing, and then check the problem, and I'll give you 3 minutes. Go for it.
Oh, okay. So first we're going to distribute the 4, so 4 times x and 4 times 3. 4 times x is just 4x plus 4 times 3, which is 12, equals 6x. And then you're going to get rid of the x, so minus 4x.
Boom, unbothered. Duh. Okay.
So then you have 12 equals 2x, and that you don't have another x to get rid of the number that's bothering the x, so you're going to make it a fraction.
Oh.
So that x equals, but that's an improper fraction. I think that's what it's called. And that would equal 6. So in the final, x would equal 6.
Now, the only thing I'm going to add here is you talk about wanting to make it a fraction automatically. Do you know why it becomes a fraction?
Because you don't have another number to get the x alone.
Kind of, yeah, you're on the right track. So remember earlier you told me that when 2 is touching a variable, or any number is touching a variable means multiply? Right, if I put like 4, you said 4 times x becomes 4x. That's
Yes.
4 times x, right?
Yes.
So what's the opposite of timesing x by 2?
Dividing.
Dividing by?
2.
Look familiar?
Yes.
Yeah, so again, that's why you can turn it into 12 over 2 to make that 6.
Okay.
All right, so now if we wanted to check this problem, this time we're actually going to be able to check it. So let's plug it in on the right side. You're saying x has a value of 6. Let's see if it works.
So you do, this would be times 6.
Okay.
So you would do 4
Inside parentheses first.
Sorry. 9.
Okay.
So it would be 4 times 9 equals 6 times 6. Then 4 times 9 equals 36. And 6 times 6 equals 36.
So does our answer work? X has a
Yes.
value of 6.
Yes.
Go to beautiful Mike.
Hey, beautiful Mike. Indeed, you are correct. So
There we
Olivia,
go.
nicely done. I like the way you explained everything. And then the way you guys were able to get X by itself because you want to isolate that variable.
Thank you.
And then you can see it doesn't really take that long to check the problem. Because with problems like this, if you don't check it, you hope you're right.
Yes.
If you check it, you know you're right.
You don't have to be
Or
bothered
if you
by
made a
the hoping.
mistake, if it doesn't work, then you know you have to go back and rework the problem instead of just kind of hoping it worked. All right, so nicely done. Great work. We'll be back with more right after this.
Like clockwork, the full moon appears every month in our sky, a sight so familiar that we often take it for granted. But about twice a year, over the course of a few hours, the full moon sports a decidedly different look. What causes this sudden change? A lunar eclipse occurs when the moon passes through the Earth's shadow, just as a solar eclipse occurs when part of the Earth passes through the moon's shadow. But the moon circles the Earth every month as it cycles through its phases, lining up at both full moon and new moon. So why don't eclipses happen twice a month? The reason is that the moon's orbit around the Earth is tilted relative to the Earth's orbit around the sun. Although the Earth and the moon always cast long shadows, they rarely shade each other thanks to the moon's orbital tilt. But if that's the case, why do eclipses happen at all? Throughout the year, the moon's orbital tilt remains fixed with respect to the stars, meaning that it changes with respect to the sun. About twice a year, this puts the moon in just the right position to pass through the Earth's shadow, causing a lunar eclipse. As the moon passes into the central part of the Earth's shadow, called the umbra, it darkens dramatically. Once it's entirely within the umbra, the moon appears a dim red due to sunlight scattered through the Earth's atmosphere. In fact, if you watched the eclipse from the surface of the moon, you'd see the sun set behind the entire Earth, bathing you in a warm red glow. Back home, you'll have to stay up late to watch a lunar eclipse, but if you do, you'll see the moon in rare form, and you'll catch a brief glimpse of our own planet's long shadow.
Always interesting things going on with NASA, and especially eclipses. Right now, we're going to head back downstairs, check in with the art kids. And Sam, I think these guys are now doing the coloring with those primary colors, correct?
Yes, they are. Well, some are choosing primary colors and some are choosing some other colors. So we've given them some freedom, or she has down here. So tell me about yours. What color choices are you going to use?
I'm probably going to use like a bunch of, I'm probably going to use like multiple colors.
You're going to go
do
like
it
the whole
throughout.
range?
Yeah.
All right, so more kind of the whole range of the color wheel. I like that. Your design looks great. Okay, how about you? What colors are you thinking?
I'll probably just use the primary colors and white and black.
All right, sticking true to the design. That looks good. Almost looks like the top of like a cityscape looking down on it. That looks very cool. Okay, and he's almost finished here. Are you going to any more black from there? Or are you going to stay with just these colors?
I think I'm gonna do one more black square and then I'll be done.
All right, you did a great job. Looks good. Okay, girls, see what we have over here. Okay, tell me about yours. What colors are you gonna use?
I'm doing red, green, yellow, and blue.
Okay. And are you gonna paint all of them, or are you gonna leave any white or black?
I'm gonna do the background blue and then
Okay.
this yellow, like the square's yellow.
Nice. Okay. And are you gonna leave some white or no?
No, I'm gonna add I blended in this shade a little.
Yeah, I like that.
I might blend in a little more.
Okay. I like it. It looks beautiful. Okay. How about you?
I think I'm just gonna stick with the primary colors in black and white.
Okay.
Yeah.
Yep. Like I said, I was telling her I love how she has some lines that are thick, some are thin, some are even have some dotted lines in there. Are you going to paint the whole thing, or are you going to leave the background white?
I think I'm just gonna leave the background white.
Okay. Looks good. All right. And your color choices?
Red, orange, yellow, the warm ones.
Okay. She's keeping hers analogous colors next to each other on the color wheel. And are you going to paint in every single one of yours?
Yeah.
Okay, I like that. I like how you're nice and bright and thick. Okay, last one over here.
I'm trying to go for more pastel colors, and I don't know.
I like
things
it.
that go good with it.
Yeah. So Dre was telling them that more water is more pastel color.
So the less water you guys use, the deeper your color will be. If you want more of a lighter color, like a pastel, like she's doing, you're gonna use a little bit more water.
Right.
You can also do a couple of techniques. So you can do wet on wet, for example. I like to wet my area that I'm gonna paint and then add the actual paint to it. If I want like a deeper, what would the word be? I guess just a deeper color, yeah, like a deeper hue. I'll do dry paper and then I'll do wet paint over it. That way it doesn't bleed and spread out.
Okay. So if people wanted to do this at home, materials obviously that they need, you just need some watercolor paper.
Some watercolor paper, some blocks. Doesn't necessarily have to be the tens blocks, hundreds blocks. You can use whatever you have at home, honestly. Anything that has a straight edge on it. Some dice, and then watercolors, and that's pretty much it.
Yep. Okay, so at the museum, what any new things going on right now?
At the moment, not that I know of.
Classes, you got the art after dark.
Yeah, we have
right?
art after dark. I teach some after school classes. We have some regular day classes where we do regular art. We've been doing some animation as well. So if you guys are interested in that, go ahead and head on down to the art museum. I'll be there.
All right, so as the kids are finishing up their artwork right now, we'll let them finish, and then you can always check our social media afterwards for the finished product. And just thank you, Dre and Bakersfield Museum of Art, for being here and for this great lesson.
Thank you for having me.
Yeah. All right, back to you, Mike.
Thanks for that, Sam. Some great looking art right now. And as you said, check out the social media later on. You can see the finished products and the way that they all turned out. Nice to see that some were using the primary colors. Others went with other color patterns. Some went with pastel, a little lighter and things like that.
Yeah, I didn't know the level of water would change the depth of the color. I thought that was cool.
Right.
Yeah.
You learned a lot of stuff today, huh?
I learned that numbers can be bothered. I'm not a beautiful co-host. The level of water in a color will change the shade. It's good stuff.
Everything's lovely. So
That's
you guys
right.
ready for a new tic-tac-toe game? This is a
There's
5
different
by
versions
5.
of
Oh, there's a lot
tic-tac-toe?
of different versions. You watch all year, you're going to get a bunch of them. Head over to the board, you guys.
All right. What in the world?
All right, so Mick, what I need you to do is just fill in, like, completely darken that middle square. There you go. Shade it all in.
It's a pro. It's a pro.
Doesn't have to be perfect, but just kind of shade it all in the way you were doing it.
Pull your pen off one time. Now go bigger. There we go. Yeah, now we're cooking.
There we go. Nicely done. All right. So, Olivia, would you like to be X's or O's?
I'll be O's.
All right. So we're going to allow you to go first. You're going to be able to place an O anywhere you want. Mick, you're an X, and you may be able to...
Ooh, that counted, right? It didn't go. Does that count as my turn twice?
All right, Mick, put your X anywhere you like. All right, keep going. You're just going to go until you fill the board up.
Oh, so there's no win.
Anywhere you want.
Can't win?
No, you're not worrying about the 3 in a row right now. I'll let you know once you fill it all in.
Okay. This is interesting. It's like a competition, but like you're not sure what's happening. It's like a speed game. I'm scared of that side. All right. She got them all in a row, right? That doesn't matter, right?
Just fill them in.
Okay. A little nervous.
All right, so now here's what I'd like you to do. Maybe change colors, Mick, to some other color. And what I'd like you to do, Olivia, is just draw a line through any 3 in a row that you have. Okay, there you go. So, Mick, any 3 in a row that you have.
Okay.
All right, so keep alternating like that as long as you have a 3 in a row.
Would it count like if you go like that?
Diagonal?
Well,
that's in a row. Diagonal.
That's what I'm saying. So you go ahead and do that one.
Now hold on. Can I like These three?
Well, see, that's what we're going to talk about.
That's I'm
once
like
you guys get going.
that's a new set of
If
three.
you're counting, now, in that case, you're counting 2 of them. Where in the other case, Olivia was only counting 1 of them.
Okay.
So
does that mean I'm more efficient, or what is it?
Well, that's what we're going to go through first and see how many more we have.
All right, keep going. Go for it. I believe in you. All right. Are we supposed to be keeping track of this?
You have 2 on the top, and you have a diagonal. So there's your 4th one.
Okay.
Olivia has 3 right now. Any others?
I don't see any.
What about these 3?
Oh, these 3 too.
Yep, that'll work.
Right.
Oh, thank you. Thank you, off-camera
There you
assistant.
go.
Thank
Well,
you.
Producer helping out there. So it's 5-5 right now. You guys got the idea of the game?
Yes.
Now that is where you can use the same O or X multiple times. Clear the board.
Off-camera help, please. What's the? Just erase it. Okay, that's what we're going
Because
with.
the board itself will stay. There you go. Cooperative work right there. You can erase the one in the middle also.
Oh, okay.
So Olivia, decide on 1 square, because there's 25, and between the both of you, you'll each go 12, that'll be 24. Figure out a square to completely black in.
Go for it.
Yeah.
So much easier that way.
Okay, so now you were able
again.
to use the same X or O numerous times. Now you may not. So it is strictly a 3 in a row without
Changing up the
using them
rules.
more than once.
Bring it on, Olivia.
So, Olivia, you are O's, go. Now remember, you can block and all those kinds of things, but you...
I feel like I'm on the defensive now. Just purely responding. No, don't be rooting back there. I hear you back there.
All right, we're going to see if anybody can get any.
Oh, great. They're talking in my ear now. People are talking to me.
And remember, you can only use each O or X once.
Yeah,
And you guys have 30 seconds. Hopefully you'll answer it up quick here. All right, so different marker. Olivia, do yours first. There's 1.
Wait,
So you can't use the same O or X
okay.
again.
I don't see any more.
Oh, you got this diagonal.
Oh, yeah.
Yeah.
All right, so Olivia's got 2, Mickey's got 1.
I think Mickey's gone.
There you go. All right, that's it. Come on over here, guys.
That was pretty cool. I
So,
like it.
Olivia, did you learn a little something today while you were here during that hour? Very good. You are now an ambassador for Do the Math, so I need you to tell people about Do the Math.
Okay.
All right? As part of your ambassadorship, you have the exclusive Do the Math Rubik's Cube also.
Yay.
All right? So, did you have fun today?
Yes.
Good. That's the most important thing right there. Remember, tomorrow, final live broadcast for our 23rd season. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.